Hello everyone, welcome to our chemistry. So in that video I will talk about solid state but in a different way. Means I will tabulate or summarize all the chemical equation here what we need to solve the numericals, and solid state numericals are important in every aspect of it in trans exam or in ISC. So this one is important for ISC, for JEE, for NEET, and for higher education means undergraduate level, for NET, GET. In every aspect this one is important. So about solid state we will just tabulate all the numerical equations and we will go for numerical solve. Let's go for it. So here are the important equation, like the radius and age length relation. And radius is represented by r, radius of atom, and age length is represented by a. For simple cubic lattice where in a cube only the atoms are present at the corner of the cube, 1 2 3 4 8 atoms shared by other error 8 cells, so unit cells 1 by 8 into 8, so z equal to 1, r equal to a by 2. For body centered cubic lattice means where at the corner of the cube 8 atoms are present and another 1 atom is present at the center of the body, so z equal to 2 and r equal to root 3a by 4. For face center cubic lattice where in a cube 8 atoms are present at the corner of the cube and another atoms are present at the center of the face, so 1 2 3 4 5 6 center of the face. So this type of lattice is face center cubic lattice. Here z equal to 4 and r will be related to a by 2 root 2. And another important relation for numerical type of problem is density. Density rho equal to z into m by ne into a cube, where z equal to number of atom per unit cell, and m is equal to molecular mass. Na is equal to Avogadro number, that means 6.023 into 10 to the power 23. A is equal to age length of the particular unit cell. And next I'm coming from the very important thing that you have to know, how to calculate packing efficiency or packing fraction. The calculation rule is we have to know the total number of atom present per unit cell. That means we have to know the volume occupied by all the atoms and total volume of the unit cell. Now this one is packing efficiency. Another thing you have to know, that is about octahedral and tetrahedral void, that is total number of atom is equal to number of octahedral void. And another thing is total number of atom into 2 will be equal to tetrahedral void. This one is another relation that we have to know. And another thing that you should know, this one is for tetrahedral void, if the radius of tetrahedral void is rt, then tetrahedral void, and if the radius of atom is r, then tetrahedral void is equal to 0.225 of r. Another thing, if octahedral void radius will be rho and radius of atom is r, then octahedral void will be equals to 0.414 into r. So these few things we have to remember for any numerical type of problem. So let's go for some problems. So see till the end, because I will discuss many problems about IIT, ISC level and NET level also. So I'm taking solid state lower level to upper level. So I will discuss every problem, many type of problem, variety of problems. So be with the end. So here it is asked, AB have simple cubic structure, molecular mass is 99 and density is 3.4 gram per cc. What is the length of the unit cell? Now as we know about the density equation, so rho is equal to Z into M divided by Na into A cube. Now the thing is, Z for simple cubic structure is 1, M is given as 99. In a Avogadro number, we all know 6.023 into 10 to the power 23, and we have to find out the A means age length. So the equation and rho is also given in 3.4 gram per centimeter cube. So the numerical is very easy. So here what we have to do, we have to calculate A. So A will be here 1 by A will be cube root of that 3.4 into 6.023 into the power 23 divided by 1 into 99. So the answer will come in centimeter. So A will be, so A is equal to 3.64 into 10 to the power minus 8 centimeter. So we can convert it in angstrom, because as we know 1 angstrom equal to 10 to the power minus, so we can convert it in picometer, because as we know 1 picometer is equal to 10 to the power minus 12 meter equal to 10 to the power minus 10 of centimeter. So as here we can write as 364 into 10 to the power minus 10 centimeter equal to 364 picometer. So the answer will be 364 picometer. So here the question is theoretical type and numerical type also, because the coordination number of a metal crystallizing in hexagonal close packed structure. So in 3D hexagonal close packed structure, how many coordination number there will be? Now, in case of hexagonal close packed structure, the structure actually is like AB type. That means suppose we have here a trigonal trigonal type of arrangement, then we will have an hexagonal type of arrangement here. That means 1, 2, 3, 4, 5, 3, 4, 5, 6, and here again this type of. So if we calculate for this coordination number 1 2 3 4 5 6 7 8 9 10 11 12, so 12 coordination number will be for hexagonal close pack. This has came in IIT 1999. This is a question for IIT 1999. Let's go for another example. Let's go for another type of example. Here it is asked, a molecule contains atom X and Y so that X occupies at the corner of the cube while Y at the face center. That means let's consider a face center cubic cell. So in case of face center cubic cell, as we have corner atoms, so total number of corner is 8. So we have 8 number of corner atom, and each of the corner is shared with other 8 cubes. So that means corner atom contribution will be 1 by 8 into 8, that means 1. So number of X per unit cell will be 1. Now coming about face center, so we have one atom at the center of the face. So 1, 2, 3, 4, 5 and 6. So total 6 number of face, and each face is shared with other 2 crystal. So each face will be shared with other 2 faces. So total number of face is 6. So it is shared with other 2 faces. So contribution is 3. So number of y will be 3. So the formula will be xy3. So like this way we have to solve. Next we will go for few numericals about NEET. So let's go for it. This one is another type of question. Here it is asked, aluminium oxide crystallizes with aluminium ions in 2/3 of octahedral holes in a close packed array of oxide ions formula. And for this, what we have to know? We have to know what is that close packed array, and in that close packed array means CCP, close packing, cubic close packing, where oxide ions are present. So as we know, in cubic type of close packing structure, oxide ions will be at the corners and at the middle of each phase, so middle of each phase. So, and another thing what we have to know, that total anion or total other atom is equal to octahedral number of octahedral hole. So what will be the total number of oxide ion? That will be the number of octahedral hole. Now oxide ion is present at corner, so contribution 1 by 8 into 8, so 1. Middle of each phase means contribution 6 phase into half, so 3. So total oxide ions will be 3. So 3 oxide ions, so total oxide ion will be 4. So 4 oxide ions will be there. So 4 number of octahedral hole. Now from this 4 number of octahedral hole, 2/3 will be occupied by aluminium. So 2/3 of 4 will be occupied by aluminium, that means 8 by 3. So the formula will be aluminium 8 by 3 and oxygen 4, that means it will be aluminium. Now we got that aluminium 4O6, aluminium 4, we can simplify it again, so by 2, so aluminium 2O3. So the formula, simple formula it is, so simple formula, the answer will be Al2O3. So aluminium oxide, answer will be Al2O3. Now we will go for some example of Miller indices, that many questions comes on NEET about that. So let's go for it. Another thing which we have to know, that one is that Bragg's diffraction in lambda equal to 2d sine theta. With this also we can get many questions. Suppose in June 2017, in part B, it was asked that metallic silver crystallizes in FCC structure and unit cell length, that means A is equal to given 40 nanometer, and first order diffraction, that means N is equal to 1, and the angle of diffraction was 30 degree, and that beam was in Miller indices was given 210. So the wavelength was asked. So how to do that? So we have to know for D at first. So to know the D, we can calculate this one. So as this one is cubic lattice, so A is equal to B is equal to C, and as we know 1 by D is equal to H square by A square plus K square by B square plus L square by C square. 1 by D square equal to, now 210 is H, K and L. Now putting all, and ABC is equal to 0, so ABC is equal to A, so that means it will become 4 plus 1 divided by A square, that means 5 by A square. So D is equal to A by root over 5. So the answer is A by root over 5. Now we got D, and we know theta means sine 30 degree. So for sine 30 degree, we know the value of sine 30 degree, like, so sine 30 is equal to half. So we have lambda equal to 2 into A is given 40 nanometer, that means 40 by root over 5 nanometer into half. Now 2 to 1, now 40 by root over 5 nanometer. Now, so the answer will be about 18 nanometer. So here we can calculate. And another type of question is, here it is told polonium is the only metal known as exists in simple cubic lattice. Density is given, atomic radius is asked, and mass of polonium means mass of each polonium atom is given. Now, as we know, density is equal to capital M molecular mass into Z divided by Na into AQ. Now the thing is, M by Na is given. M by Na is here, that thing 2.7 to 10 to the power minus 2, and for simple cubic lattice Z equal to 1, and A cube we have to calculate, and rho is also given. So that means A cube is equals to M by Na is given. So rho is equal to this, we know Z equal to 1 for simple one. M by Na per atom weight is given, so A will become 3 into 10 to the power minus 8 centimeter. Now as we know, for simple cubic lattice, the arrangement is like that, here 2 atom. So here this one is A, So A is equal to 2r, that means r equal to A by 2, that means here it will come 1.5 into 10 to the power minus 8 centimeter. So that means 1.5 into 10 to the power minus 10 meter, this one equal to 1.5 angstrom. So the answer will be 1.5 angstrom. And the next question is, so here it is asked that what will be the Miller indices for this plane. So as we know, Miller indices is the reciprocal of Weiss indices. Now here for Miller indices, if we can see, if we can draw this type of cubic lattice, so here there will be many plane, and suppose we have this plane, and this plane will be equals to 220, 220, because it has cut by two amounts, so no z, so only x, y, a, b, no c. So like that way, if we have taken, so suppose we have considered one small part, then as you can see, the small part contain this type of thing. So this part is half of this part. So this part is 1, this part 2. So no z is there, so 120. So the Miller indices will be 120. Now, if this video is helpful to you, please like, share, and subscribe to my channel. And don't forget to comment that what type of video you want. And thank you very much for watching.